Yeah, it's a current probe. I've never seen it before in my life. I don't know how to use it. It's here. But there was a very impressive thing somewhere. Is it this one? Maybe. See how this goes. Yes, this one. Does anyone know what this is? So, the first day I came here and I'm like, what do I have to do? And someone opens this box and he's like, what is this? We don't know. Organize it somehow. I'm like, so I googled up this thing. This proves to be some old-fashioned wavelength calibration system. Like you put one antenna here and one antenna on the other side, and you can very precisely, down to the micrometers maybe, adjust the distance so you can capture the wavelength.
We had quite a few of RF guys some 10 years ago.
I believe
measuring on antennas, designing antennas, and so on.
Someone was doing
stuff
RF hardware job really seriously. So
yeah.
we have equipment that I have never seen before in my life. Anyway, that's the lab part. And the second part is the 3D printer. The 3D printer at the moment is operational, but it lacks some things. I have ordered a Wi-Fi SD card, which I'm going to hook up and then somehow make it public, so anyone can upload a sketch to print directly on the printer. Because as it is now, you will have, if you want to print something, which there is a very nice wiki page. Maybe we should send the wiki page after this session to everyone.
I will send it and I will show it also during the meeting, if I find my computer.
I also have it here. There is a wiki page that describes the way they used to work with the printer, which is you booked it, and it had the laptop next to it, and people had to go to the laptop and bring their design with them and use the slicer and slice it and upload it on the SD card, remove the SD card, put it on the printer, and then print. So, I know everyone uses his favorite tool to design 3D parts. For example, I used FreeCAD to design this. Very simple Cybercom demo. And then you have to use the slicer for this particular printer, which is this one. And then this slicer produces the instruction set for the printer to work, which is what you put in the SD card, and that's what you print. So we are going to automate that process a little bit, so it's easier to use, and there will be new instructions on this wiki page on how to do it. Bottom line, you design your part in your 3D CAD, your favorite 3D card, and then you use the slicer that the company provides for the printer. You extract the instructions, put them in the SD card, and you print directly from the printer. And because the prints take like, this took 30 minutes. And I printed it just before this session, and it's in there now. You can go and take a look if you like. But a cell phone stand, you can imagine the dimensions, like that would take 8 hours to print.
Is it possible to reproduce the steps now and that you show us so we trigger some prints?
Yes, absolutely. So
maybe later in your computer if we can see all the process.
Everyone can see, right? No, but sure. So, can we hook it up here, Gabriel?
Yeah, sure.
Because
so I'm coming on Monday. I want to print something.
So,
and what do I do?
My suggestion is, if you want to print something, you already know how to use a 3D CAD and you already have designed something, or at least downloaded it, right? So you don't need the instructions on how to design something. But after you design something, using your favorite CAD, mine is SolidWorks, for example, but I don't have SolidWorks on this PC here. So you get somewhere here, for example, where you have your final product ready, in 3D CAD. So you have to export it. The most common, the most common format that everything works with and everything recognizes is STL. STL. So I will export it as an STL, and we will name this Cybercom test 2. So now I'm done with my 3D CAD program. I'm finished with my design, and I go to the slicer that comes with the machine. It's the company slicer. It's a pretty good slicer actually. It's called FlashPrint. This software you can download from the website of the company. The instructions are already in the wiki. So you go in here and you import or load file the design. So in my case it was Cybercom test 2. And it will appear in a random position here on the bed. You can have adjustment, you can move it around, you can play with it, put it wherever you like. If it is a more complex geometry, let me give you an example. We actually ordered something called water-soluble filament. And it's a special plastic that once you immerse it in water, it dissolves. And the use for that is if you have internal cavities in your design. The only way to print them accurately is to have the second nozzle of the printer fill that space with a water-soluble filament and then wash it away once you're done to create the cavity. Otherwise, if there is nowhere for the head to print on,